This meeting is being recorded.
All right, sorry about that. We're back. Chris is
What the
going to
heck?
continue his explanation. What's wrong?
Yeah, I don't know what happened, but I'm like on the. Oh, wait, never mind. I'm back. I'm good now. I was on like some like pay page. Anyways, I have no idea where I left off, honestly, because the meeting just ended. Um, but I can go back in time. I think I was talking about 1995. So essentially, yeah, they found with the thymus, they were expected, in these mice that had a removed thymus, they expected a weaker immune system. Instead, it was the opposite. They saw a greater immune response. Essentially, this led to this scientist hypothesizing that maybe the thymus, maybe where the T cells are being uh, trained, has to have some important aspect in suppressing the immune system. And essentially, he was able to find that a subset of these CD4 plus T cells, when he inserts them back into these mice without the thymus, was able to prevent these autoimmune diseases. And essentially, he found, the our new regulatory T cells, which he called TREGs, and it was the first concrete evidence of a peripheral immune tolerance, which is like, you know, a secondary uh, regulation of the immune system, which was, that which wasn't known yet. Um, and then essentially in 2001, uh, these other scientists went into trying to figure out like if there's an actual master gene or master control of, these Treg cells. Essentially, they used mice that had similar autoimmune issues, and they found that with genetic analysis that somewhere on the X chromosome was responsible for causing these defect. And by a lot of complicated biochemistry and and biology, they were able to narrow it down to 20 potential genes in mice, and eventually were able to transfer that knowledge into humans. And they found the a new gene called the FOXP3 gene, and this gene, when mutated, causes the immune system's collapse, uh, and prevents it being regulated. So why is this important? Like why do we care about this? A few ways. One, pretty much all autoimmune diseases come from the body not being able to regulate itself. Your T cell, your immune system has to be strong enough to eliminate all these bacteria and all these other foreign viruses and whatnot. But at the same time, while your immune system's not strong, it can also do bad things to yourself. So you got to really be able to prevent, uh, this. And then at the same time, if maybe your immune system, this peripheral or tolerance system is working too well, and your immune system isn't doing anything, it's constantly being checked and stopped, and that can lead to cancer. A lot of cancer is stopped when in early stages when these immune cells are able to go kill the cancer cells on their own. So yeah, without if the break's too strong, you're going to have cancer. So essentially, one of the ways they're using this is adoptive cell therapy. And the idea is to take tregs are harvested from the patient, taking to a lab, multiplied, and then reinfused back into the patient. And the idea is to halt the progression of autoimmune diseases like Crohn's or type 1 diabetes. And so far, they're in mid to late clinical trials, which are showing that this is a possible way of treatment, and it's also safe. Looking ahead in the future, in the future, ideally they'll have engineered tregs, and essentially the idea is that to improve specificity and potency of treg therapy, you're gonna essentially use a gene editing tool like CRISPR, and you're gonna put like a specific receptor on the treg surface, on the surface of the cell, um, so you can target a single specific antigen. For example, if you had a transplant, you could engineer one of these tregs to have the transplanted kidney specific antigens. So instead of your immune system attacking this transplanted kidney, you would suppress the rejection, but without causing like global immune suppression. And then another issue with this is, uh, it's hard to get these car or these Treg cells from the body, because they're not very prevalent in blood. So additional research that they're aiming to do is be able to take, these pluripotent stem cells, which are like pretty one of the most flexible stem cells there is, and turn it into Treg cells in the lab, uh, and then, be able to, you know, engineer these Treg cells to do specific antigen receptors. So yeah, a lot of involvements in immune disease, autoimmune disease, and hopefully at the same time, if you can find out how to maybe stop these halt these Treg cells, you can also prevent cancer and other viruses and bacteria infections and whatnot. So yeah,
It's awesome. Thank you, Chris.
yep,
All right. Now do you want to, I guess, tackle the chemistry one together?
yeah, sure.
All right. Do you want to start or do you want me to?
You can go for it, or
Okay.
I can, whatever you want to do.
Yeah. Um, yeah, I can do it.
All
So,
right.
yeah, basically the Nobel Prize in Chemistry for the year 2025 was again awarded to three scientists. I'm not going to try out their names, but they they showed kind of the creation of metal organic frameworks that I guess can be thought of as rooms. So they're constructions, molecular constructions, and I guess kind of like the best way to think about it for somebody who doesn't have any background is like on a very very small level. Like if you think about a metal, you have individual metal atoms that are in a lattice together and are bound together through a metallic bond. So you would have like one atom bound to another atom, bound to another, and they would form this grid, this 3D lattice. And that is on kind of the microscopic atomic level what a metal is. And then obviously kind of that translates to the metals that we get and that we experience in our real lives. And so one of the scientists, he had an idea as he was kind of doing an activity with his class way back when, way back in the 1970s. He was doing an activity where they would essentially assemble these atomic structures, like actually physically. They would have holes and they would have atoms and they would build bonds between them. And he kind of thought to himself, where how you assemble the structure actually dictates a lot and gives it a lot of unique properties and how it interacts with different things. And so he was thinking, what if we made more complex frameworks? What if, instead of kind of these simple atomic structures, we used molecules and we kind of bonded them together in these complex metal organic frameworks. And that is kind of the basis for what ended up happening. Um, Chris, you got anything to kind of add or say beyond?
Yeah, no, I think it's pretty innovative that like to be able to like alter these like the atom size, be able to make these like small rooms or whatever you want to do. I was reading a little about it, and I thought it was pretty cool how like these can prevent like lead to be able to like capture CO2, CO, for example, like capture they can capture emissions such as CO2. Uh, they can also use to harvest water. If you live in a really dry desert environment, you could use it to harvest water from the air and make drinking water. And then additionally, there's other ideas of being able to use to filter or break down microscopic pollutants, such as like heavy metals in the air or in the water. But yeah, and also I'm reading about it now. There's ideas to store gas, such as like hydrogen gas and methane. It can be used as catalysts, and then also maybe potentially delivery, or biosensing. So yeah, a lot of different ways that this like foundational discovery can be led to a lot of different applications, all the way from on the industrial side or environmental side to even delivering a drug, which I think is pretty cool. Anything to add, Ian?
Um, I don't think so. I mean, I think you hit it pretty. I mean, I guess for anybody who doesn't like have a big background in science, some of this stuff probably seems pretty confusing. Um, so I don't know. I guess if I was to like think of a way to explain this for anybody, no matter what kind of experience or background you have, it's like it's like you're building a house on the molecular level. Let's say you're building this structure using different molecules. Different molecules have different affinities. Um, And so if you want to capture something, if you're trying to capture some sort of gas, if you're trying to, like Chris was saying, um, capture water in these arid, hot environments, um, you can build a structure that will selectively kind of bind and capture that. And it's exactly like you're trapping it. You're just trapping it on the molecular level by selectively building this thing that will bind to it.
Hmm.
And so, I mean, a lot of this stuff, I guess, seems pretty abstract, but I think, like, in a lot of ways, it's just taking kind of basic fundamental ideas that most people can intuitively understand and just making use of them in an extremely technical and, you know, kind of in depth scientific way.
Yeah, I really like that explanation, Ian. Yeah, like it's all really complicated, but a lot of this is based on fundamental things that, at the end of the day, a lot of like this stuff comes down to like, I don't know, they're making a specific shape so it fits a specific thing, like, which is like cool, but it's also it's really cool that they can do this at such a small level, and there's no limits on what this could be used for. Yeah.
Yeah. All right, Chris, you have anything else about our Nobel Prizes you want to add? Any other comments?
No, I don't think so. No. Um, I think everyone should be on the lookout for our next episode. It's gonna be very, very good,
Yeah,
to say the least.
it's going to be great.
But yeah, um, a little bit different. Going a little bit back to our roots of the science. Like, I actually, for honestly, I really like these science episodes. So I'm sure
Yeah.
it's probably boring for people watching, but hope maybe we can do a little bit more in the future. Yeah,
Yeah, it'd be cool. We could start like picking some complicated topics, maybe trying to really explain them, walk through them.
yeah, I think that could be a good like individual episode we could do. But yeah,
Yeah. Hmm. All right. Yeah, I mean, thank you all for watching. You know, we love to have you. So,
yeah, good time as always. Yeah, thank you.
all right, stay cool, stay free, love your brothers, love your sisters. Let's go. Let's
Peace.
ride.